All right, so now we're going to look at how to complete the square to get vertex form if your leading coefficient is not equal to 1. So let's go up to this first problem right here. Again, the reason we want to go to vertex form is because once you know your vertex, you can use your pattern of over 1 up 1, over 2 up 4, over 3 up 9 to create your parabola. It's way faster than just getting your x-intercepts and doing it that way. Uh-oh, why is it doing that? All right, so now, that's annoying. Okay, whatever. So if your leading coefficient is hanging out in front, it might be, there's two ways to start. You can either start by dividing through by the leading coefficient, or if you wanted to, you could start by subtracting your C value. Either way is fine. It doesn't matter at all. Right now, I'm just going to divide everything by the leading coefficient. Leading coefficient is 3, so I divide both sides of my equation by 3. And now on one side, I get y over 3 equals x squared on the other side, plus 4x plus 2. And now I have a c term that I'd like to get rid of. I don't want it on this side. That being said, some of you may be looking at this and going, oh, it's almost a perfect square if I added 2 more tiles, but let's pretend you don't see that. So if you were to draw this out, you write your y over 3 again. Oops, sorry. You're going to subtract 2 from both sides first. And we have y over 3 minus 2 equals x squared plus 4x. And now we can complete the square right here. So I have an x squared tile, and on the other side I've got y over 3 minus 2. That looks a little crazy, but don't worry about it, just let it hang out over there. We'll fix it later. And then we have these positive 4x tiles. We're going to split them up, so we have 2 there and 2 there. So in terms of algebra tiles, it's going to look like this. So I have x squared plus 4x, same amount on both sides, because we're trying to make a square where the length and the width are the same. And how many tiles are we missing? Well, 2 by 2, or 2 times 2, gives us 4 tiles are missing. Right there. So I'm going to have 2x on both sides, which means my length and my width are x plus 2 times x plus 2. And then the piece that's missing in here that I need to add is 4 unit tiles. Now I have to add 4 to the other side as well to keep my equation balanced. All right, so on this side of the equation, if I combine like terms, I have y over 3 plus 2. And on the other side, I now have this perfect square with a length and a width of x plus 2 squared. I want to solve for y now, and at this point I'm going to be subtracting this 2 from both sides, minus 2 on both sides. Now I have y over 3 equals quantity x plus 2 squared minus 2. And the last step is I have this divided by 3. So if I have that divided by 3, I need to multiply this side of my equation by 3 to cancel it out. But if I do that, I also need to multiply the other side of the equation by 3. When I do that, I'm going to multiply the 3 by my perfect square, and then I also have to multiply it by that -2. So I'm going to do the distributive property. It's going to go there and then over there. And I'm writing really big, so I guess I should shrink this down a little bit. And so those y's, those 3's cancel. I have y on that side. And on this side I have 3 times x plus 2 squared minus 6. I'm actually going to move that over here. All right, and now I can see my vertex. So my vertex is my h value. If I were to compare this to the formula, my h value is going to be -2, because in order to have minus h turn into a positive up there, that means I'm going minus -2, and that's how I got that positive. And then my k value, ooh, that's not a highlighter, is the -6 at the end. Cool, so now I have my vertex, right? So I'm going to plot -2, -6. So I come over here, back 2, down 6. There's my vertex. Now, I can't just do my pattern where I go over 1, up 1, over 2, up 4, because I have, alert, alert, an a value. So I have a dilation right here. This is going to make my parabola grow 3 times as fast. So let's carefully plot this out. So instead of going over 1, up 1, I go over 1 from the vertex, up 3, because everything's going to be multiplied by 3. Over 1, up 3. So this parabola is going to be rather skinny. And then over 2, instead of going up 4, I have to do times 3. So 4 times 3 is 12. So I go over 2, up 12. Way up there. So there's that point. Over 2, up 12. And then we are running out of paper. So we're just going to sketch our parabola with those 5 points. Notice that we can now check our y-intercept at 0, 6 and see if it matches our standard form. And it does. Yay. There's that y-intercept. So just to recap, when you have a leading coefficient that's not equal to 1, it gets a little messier because you have to divide everything by the leading coefficient. It's up to you if you want to subtract the 6 first or if you divide first. It doesn't really matter if you move the c term over before or after you divide by your leading coefficient. It does mean that you're going to have, at the end, when you're solving for y, you end up having a little bit more work to do, right? When we had to multiply both sides by 3, we had to be really careful about using the distributive property. You multiply your perfect square by the 3 and the k value by the 3. And that's how we got our vertex form. When you get to this problem, your leading coefficient is -1. So you're going to divide both sides by -1, which will turn this into a -y. And then at the end, you will have to undo that by multiplying everything by -1 again.